my biggest takeaway from working on this project is that this is a really underrecognized problem, and machine learning is a really good solution. It's pattern recognition. We've proved that it can be done pretty well with a machine learning approach, but I would be happy if more people read about this problem, familiarized themselves with what IV fluid contamination could look like in their patient specimens. And when they are working on the floor and they do see something suspicious, that they say, I remember hearing about this. I think this might be a contaminated specimen. I'm gonna do a double check before I, order blood products. I'm gonna do a check to make sure that I'm not acting on a false BMP result. So just talking about this more and making more people aware of the issue, I don't wanna say is good enough for me, but, that I think is a step in the right direction, and I think this is a problem that more people should be aware of and should be talking about.
Replacing the day-to-day work of laboratorians and pathologists?
That's a good question. I think something that I've heard, like, this isn't a novel idea, is that there's a lot of use for AI, there's a lot of potential for machine learning, and it's really important that we ask the right questions. For example, I don't need a model that takes all of the patient information and spits out a yes no answer to, does my patient have acute myeloid leukemia? We have clinicians, we have hematopathologists who can do that. So that's not a question that I necessarily need answered. That's not a workflow problem that I need solved. The things that I think would help me the most are things that help me do my job faster and help me get to a more accurate result. So, for example, there's a lot of potential, at least in the laboratory, for machine learning and things like flow cytometry. A lot of the pre-processing and the gating is really manual. That's a great use for machine learning. It's pattern recognition. That's something that machine learning can do really well. That's a hang up in our workflow. So something like that could do it faster is I think where we should put our efforts. Um, Another thing about this project that I mentioned earlier was that we don't have a really good way to do this in the laboratory as is. So humans aren't very good at it. The techniques that we have right now, like delta checks, they're not designed to have high sensitivity to IV fluid contamination. So we are filling a gap. With that being said, because there's no gold standard, these things are pretty difficult to validate, and to prove that this is truly IV fluid contamination and not something else. So, when you choose to go after a problem that there's not a really good gold standard, you should be prepared to rigorously validate it. Um, and that's something that as we move forward, we're going to have to do as well. Uh, and it is a challenge, but it's not an insurmountable challenge. That's also a really good question, and that's something that we're working on, next. So, there's kind of 2 routes we could go with this. I think the route that would be more familiar to what we do in the lab already, would be to use the retrospective models that we already have as a tool for quality improvement monitoring. So, for example, right now in the hospital, contamination of blood specimens, not IV fluid contamination. The contamination that when you say the word contamination, most people think of is a metric that the hospital follows really closely and has is very incentivized to keep low. So we have various tools to try to prevent contamination of microbiology specimens, blood cultures. One of those is education. So right now we're working on more advanced educational tools to decrease that contamination rate. We could do something very similar with, IV fluid contamination, trying to target that problem through, education of phlebotomists, nurses, anyone who draws specimens in order to educate them on the problem and then also provide some best practice tips on how to avoid this. Something that we've seen is that this problem is not widely recognized, and the consequences of this are something that not everyone really understands. But like I said, we're really trying not to put false results in the patient chart. So we could go an approach like this where we have an educational, I guess, initiative roll that out, and then over time, using the retrospective algorithms, see if there is an improvement in the, IV fluid contamination rate. So that's a use that we have for the models that we already have. The second way, which would probably be a bit more involved and a little bit more difficult because it would involve validating an it's entirely I mean, it's similar, but an entirely different model, would be to take similar take a similar approach and design and validate prospective models. So right now, the retrospective models work with a prior, current, or possibly contaminated, and a post result. And if we wanted to use this in real time, we wouldn't have that post result. We'd have to make a prediction on the prior and the current. We have those, like they're in the works. Obviously, the performance of those isn't as good as the retrospective algorithm. So we have a lot of work to do validating, um, and really working on the positive predictive value for it to be high enough to do something like delay the release of blood products, if we thought something was possibly contaminated. So the work that would go into that would definitely involve some prospective validation. For example, um, anything that was predicted to be contaminated, we could draw either a point of care hematocrit and make sure that that hematocrit is actually higher than we think it is. We could do something like test glucose on a specimen, on a patient who's on a dextrose containing infusion. So there's ways to prospectively validate the results that we're getting. That just takes work, and those would be some they're not impossible, but they would be different trials that we'd have to do to validate this. So those are the directions we're going in. There's really nothing stopping us from going the education route. We know this is a problem. We have the tool to monitor, to see if our solutions are working. That's something that we can get started on right away. The prospective real time, um, takes a lot of work, and it also would require us to integrate these models into our workflow, into our lab information system. That's a whole 'nother can of worms. That's, something I would say for a real, like, machine learning expert to talk about, but that is something that really requires a lot of infrastructure, a lot of work with your IT team, a